So sorry for the mishap. So we were trying to figure out what we multiply the square root of 2 by to get 1. So if this were just 2x equals 1, how could we solve for x? You could divide both sides by 2, and so you could multiply by 1/2. Well, this is no different, only we're going to divide both sides by what? Square root of 2. So the factor that we're multiplying by each time is 1 divided by the square root of 2. So 1 times 1 divided by the square root of 2 is just going to be 1 over the square root of 2. But I don't like 1 over the square root of 2. Why do I not like 1 over the square root of 2? It's got a radical in the denominator. Good. So we have to get rid of that. How do we get rid of it? Multiply by the square root of 2 over square root of 2. The square root of 2 then becomes, what's the square root of 2 times the square root of 2? Square root of 4, which is just 2. So this distance from here to here on my x-axis is square root of 2 over 2. And then my height is going to be exactly the same, square root of 2 over 2. So the coordinate at pi over 4 is going to be the square root of 2 over 2, comma, square root of 2 over 2. Every single one of you need to write that at pi over 4, the coordinate that you must memorize is the square root of 2 over 2, square root of 2 over 2. Now that's in quadrant 1. Is my 45, 45, 90 triangle going to be any different in quadrant 2? No, but is my coordinate going to be different? What's going to be different about it? It's going to be negative square root of 2 over 2, but still my y coordinate is going to be positive square root of 2 over 2. In quadrant 3, what do we know about both of those? They're both going to be negative square root of 2 over 2. And in quadrant 4, my x-coordinate is going to be a positive square root of 2 over 2, but my y-coordinate is going to be negative. Now, just as we had a 45, 45, 90 triangle, and we found out the relationship there, we also have a relationship with our 30, 60, 90 triangle. So I'm going to go to this last unit circle. If I come all the way out here and create a 30, 60, 90 triangle, this is 30, this is 60, and this is 90. Anybody know what the relationship for 30, 60, 90 is? Anybody remember it? There is a square root of 3. It is 1 square root of 3, 2. 1 square root of 3, 2. So, but what is my hypotenuse in this triangle? 1. So how can 2 turn into 1? Divide by 2 or multiply by 1/2. So 3 times square root of 3 times 1/2 is just going to be square root of 3 over 2. And 1 times 1/2 is just going to be 1/2. Okay? So the coordinate here, remember our opposite over our hypotenuse, adjacent over hypotenuse, all of that should be coming back to you. We did a SOHCAHTOA. Remember that stuff? So if we do opposite of 30, it's going to be 1/2. And opposite of 60 is going to be my square root of 3 over 2. So I go out square root of 3 over 2, up 1/2. If you look at your calculator, if you were to plug the square root of 3 over 2 in your calculator, you're going to get a decimal that rounds to 0.87. 0.87. And so 0.87 is longer than 1/2, right? That's why this triangle is longer instead of taller. What do you think is going to happen when we go up here to 60 degrees? Well, taller than longer, so you go out the shorter amount, so they switch. So this, it's just going to be 1/2 square root of 3 over 2. To give myself some room. You don't have to have your coordinates by Friday, but you do have to have your degree measures and your, I'm going to give you some, although the coordinates, once you memorize them, they're not that bad, because what's this going to be over here? Negative 1/2, and then square root of 3 over 2. Sorry. What's 5 pi over 6 going to be? Negative square root of 3 over 2 and 1/2. 7 pi over 6 is going to be negative square root of 3 over 2 and negative 1/2. This one, 4 pi over 3, is going to be negative 1/2 negative square root of 3 over 2. Over here we have positive 1/2, but negative square root of 3 over 2, and positive square root of 3 over 2 and negative 1/2. So once you learn these first 3 coordinates, you really should be able to reflect them around the rest of the circle. I hope that this helps. I'm going to leave this up for you guys for a second. To my video people, I hope you're having fun in Boston or robotics. Bye.